So, so, um, why do we use plastic? Because it's pretty convenient, but more so than the convenience, we really, really need plastic to do a whole lot of things. They are convenient, they're inexpensive, um, and they have revolutionized our way of life considerably. So they contribute to new innovations, life-saving products, and they've transformed healthcare. For example, a whole lot of healthcare, biomedical devices that we see, prosthetics, catheters, and so on, they contain plastic. And in some cases, these devices would not have even been possible without the use of plastic. So the reusability of plastics also means that we are reducing waste in a way. So think about this example. A plastic bag versus a paper bag. I really like to bring this example in when we are talking about the life cycle perspective of impacts. So if you're using a paper bag for something, it is likely that it is most likely to be single use. You are not going to be able to use the same paper bag over and over, especially if you think about an application like, let's say, which requires a reasonable level of hygiene. So plastics, on the other hand, can be reused. So if we compare that reusability of plastic to a single-use paper bag, it often turns out that plastics have a lower life cycle footprint. A single plastic bag has a lower life cycle footprint compared to a paper bag. So in some cases, that leads to reduced waste, reduced embodied emissions, and reduced overall impacts compared to alternative materials. The lower weight of plastics translates to a reduction in transportation costs, lower fuel usage. And plastics can be used in tough environments or special environmental conditions due to a lower tendency to corrode. For example, you can use plastics in locations close to the sea or marine environments just because they don't corrode, so they last longer. So I've been telling good things about plastics. Why am I telling all these good things about plastics if we say that plastic is a problem? So regardless of how convenient plastic is, and especially because of this convenience, we've created a throwaway culture surrounding the use of plastics. Because it's so pervasive, you find plastic everywhere, it's cheap, it's easy to access, it's easy to produce. There's this throwaway culture, and we are creating a lot of plastic waste. And I'm going to talk about the scale of that throwaway problem, the waste generation problem associated with plastic in just a little bit. But what makes plastic a problem is this throwaway culture, the non-biodegradability of plastics, the issues related to plastics ending up in landfills and the pollution associated with that, the ecological damage created by plastics, and microplastics, especially these days, as well as the climate impact of using plastics. So this is the status quo that you're looking at. If you can see this image, you can see that this is what you have within a normal household. So in every room of your own household, you're going to find plastics, whether it's a computer or phone that you're using right now to engage with this session, your devices like the headset or tablet, and then your backpack, uh, the mattress in your bed, in some cases, your backpack, the garbage bin in your kitchen, the kitchen appliances, all of these things contain plastic. And if you go beyond that, if you take your vehicles or garden or office, everywhere you will find plastic. So it's just, it looks impossible to get rid of plastic just like that. Life, as we know right now, would not be the same if we did not use plastic. So if we are to find a solution to all these problems created by plastic, we have to acknowledge the fact that it is being used everywhere. It is essential in many applications, and we have to find viable alternatives that replace plastic while still delivering the same benefits in order to find solutions to these problems. So what are the sources of plastic waste? In talking about that, we have to look at the plastic life cycle. So we are looking at the extraction, and the raw materials for plastics are extracted from different sources, but they're, like I said, mainly fossil-based these days. And then plastic is produced. It is sold. It goes to the consumers who use the plastics, and then waste is produced. And then there is going to be dumping and burning. Or in the ideal scenario that we have right now, the most ideal scenario, recycling. So plastic waste can intentionally or unintentionally enter the environment during different phases of this life cycle. The entering of plastic waste into the environment is the most problematic at the end of the life cycle, where waste is generated and dumped, or litter is created, or it is disposed of in various ways, including burning. But it happens at all these other phases of the life cycle too. Say, for example, during plastic production, waste plastic gets generated. And in many cases, it's just dumped. That also adds to the plastic pollution problem. So who is the biggest culprit in creating the plastic waste or contributing to the plastic pollution? It is the packaging industry. The packaging industry accounts for around 35 to 40% of the global plastic usage. But in addition to that, all these other industries, fashion, manufacturing, construction, agriculture, fishing, and healthcare, all these sectors contribute to plastic pollution. So plastic pollution can originate from the resin pellets being leaked during the plastic production, mismanaged waste or litter, abrasion, so rubbing of plastic material, the abrasion resulting from that, which leads to loss of microplastic particles, industrial and marine activities, like, for example, the fishing nets that just get discarded into the marine environment, catastrophic events, like, let's say, shipwrecks leading to the release of plastics into the environment, and then urban wastewater and stormwater runoff. For example, it has been found that washing machines, the wastewater coming out of washing machines, is a big source of microplastics entering the water cycle. So these are the sources that we are looking at. And here you can see the shares attributed to the different industries. As you can see, this light blue is the packaging industry that accounts for the biggest share of plastic waste. But building and construction, transportation, consumer and institutional products, textiles, electronics, and all these other industries, like, for example, healthcare industry, all the biomedical devices that are used and discarded from the healthcare industry. So what happens when we use these plastic products? Different plastic products have different lifespans. Some of them remain in use for a very, very long time period. Some of them are discarded immediately. Think of the packaging that you have around food products. Like if you go to the supermarket right now, you're going to see that most of the food there is packaged in some sort of plastic, other than the tin cans and the I would say the glass jars that you have. Everything else is you and the paper containers. Everything else is likely to be covered or wrapped in plastic. So this is immediately discarded and it enters the environment. The plastics that you have in your electronic devices or the plastic that is integrated into the durable goods you use in your households, like appliances or furniture, that is going to last a little bit longer, sometimes years. The plastic that is integrated into, say, solar PV systems, that's going to last even longer, say 20 years maybe. But at some point, this plastic becomes a waste material. So what we have to keep in mind is that plastics do not become waste in the same year that they entered the market. So the plastic that you create today doesn't become a problem immediately. It becomes a problem at some point down in the road. And you may not be the person who has to solve that problem. It's your children or grandchildren. And to just show the scale of that problem, as you can see, the plastic products that are used in the building and construction industry that were used in the 1970s are becoming waste material right now. So this may be your parents' house, this may be your grandparents' house, or this may be an office building that was constructed a long, long time ago, but you are the person who either has to solve this problem or has to suffer from it. The plastic material that was used in the automotive industry in the early 2000s is now becoming waste. Electrical and electronic appliances around, say, 5 years or a decade ago. So whatever you're producing now is going to become a problem towards the end of the century if we talk about the building and construction material. If you talk about the automotive industry, it's going to become a problem around mid-century. So the variable lifespans of different plastic products and parts helps to explain why waste quantities for a given year are considerably smaller. They are much smaller than the total plastic products and parts entering the market for the same year. So you cannot estimate the scale of this problem by just looking at what you're producing today. And that is why this pollution is becoming exponentially bigger as time goes on. With time, we are consuming more and more. So we talk about all these things like globalization, connectivity, better quality of life for people, industrialization, and all of this. But the issue is that all of this is connected to more and more consumption. So we are a very consumption oriented, a consumerist culture. And the more that we consume things, the better our lifestyles are, the better our quality of life is, the more industrialized we are, the more we consume, and the more uh, of a problem we have in terms of pollution. So we are looking at the status quo right now, the business as usual scenario, and we are looking at this sort of waste generation. So we have around 380 million metric tons of fossil-based plastics, and most of it is going to be mismanaged. Compared to that, the amount of bio-based plastics that we have in the market right now is pretty small. So we call the current use of plastics a linear economy. Any idea what a linear economy is? And you can use the chat to provide your answers or provide your info, or engage in the discussion if you like. What is a linear economy? Any idea? Oh, I'd like to ask this question. Is a linear economy a good thing? Yes, go ahead, please. I see a raised hand. Yes, is a linear economy a good thing or a bad thing? So a linear economy is take, make, waste. Yes, good, good summarization of the situation. And we have these answers saying that it is the take, make, waste model. And I have an answer that says a circular economy is good. So yes, a linear economy is not a very good thing because we are using material, we are extracting material, we are using the material to produce goods that are used once or maybe a few times before being disposed of. So you're right in saying that a linear economy is not a good thing because in a linear economy, things end up being disposed into the environment, creating waste. And the issue with this waste is that you're moving away from the natural life cycle. Now, if you talk about nature, you have any waste in nature is used as an input to the next cycle. So it's a circular process. Say, for example, fish eat plankton and algae. They go through their life. The fish die. They decompose, become fertilizer for the next generation of algae, and so the cycle continues. Now, when we have a linear economy, a man-made linear economy, we are moving away from this because we are turning natural matter into something else that does not enter back into the natural cycle just like that. So the plastic products that are designed for the global market usually have this linear economy model. So globalized supply chains fail to account for the realities of local waste management. So In many places, we don't have very good waste management practices or systems or infrastructure. So it's very difficult for them to deal with the waste problem. And therefore, so with the globalization, we have all these goods entering the market, but we don't know how to deal with them. And we don't have consistent definitions or standards or metrics with regards to how we account for this waste and how we deal with it. And there isn't sufficient transparency. So if we talk about the scale of this pollution problem, humanity produces more than 430 million tons of plastic annually. 2/3 of this is short-lived and it becomes waste, enters the ocean, and works its way into our food chains. So every day we are dumping around 2,000, the equivalent of 2,000 garbage trucks full of plastic into the oceans, rivers, and lakes. And every year, around 19 to 23 million tons of plastic waste leaks into aquatic ecosystems. So it pollutes lakes, rivers, and seas. Around 46% of plastic waste is landfilled, 22% is mismanaged. So landfilling is still good. Landfilling means that you're actually collecting that plastic and then it goes into a landfill. That has other issues associated with it, but it's still not litter. Litter is mismanaged and irregularly dumped waste, which then enters sensitive ecosystems and becomes a huge problem. In 2019 alone, plastics generated around 1.8 billion metric tons of greenhouse gas emissions. So if we talk about the cleanup, it would take 67 ships a year to clean up less than 1% of the Great Pacific Garbage Patch, which is something that actually exists in our oceans right now. Each year, more than 100,000 marine animals are killed by ocean plastic waste. And the plastic pollution is predicted to double by 2040. So around 15 years by now. And it has more than doubled in the last 2 decades. And the rate of doubling is getting it's getting higher and higher. So we are generating plastic waste faster and faster. So if we talk about the life cycle of plastics, and I did talk about this a bit before, a plastic bag lasts for about 20 years before even starting to degrade. A coffee cup around 30 years, straws 200 years. If we talk about plastic cups, disposable diapers, toothbrushes, these last in the scale of about half a millennia. So biodegradation is the process of natural breakdown of any material by the activity of microorganisms like bacteria or fungi into simpler non-toxic substances. So if plastic were to break down, it has to, because it's a hydrocarbon, it has to break down into something like carbon dioxide, water, methane, biomass, and so on. The issue is plastics don't biodegrade that easily. They are very, very difficult to biodegrade. So the polymers that make up plastic are long, strong, chemically stable, and they're pretty resistant to microbial attack. So in 2016 alone, the world generated 242 million metric tons of plastic waste. And if you look at the seashores, you're going to find drink bottle caps, bottles, cotton buds, wrappers and crisp packets and so on, plastic bags, cutlery, stirrers, drink cups, balloons, food containers, all sorts of things are turning up on our shores. If we don't make any changes to the current situation, the plastic waste generation is projected to triple by 2060, up to 1 billion metric tons. If we look at the marine litter right now, currently, you're going to see, give me one moment, you're going to see around 18% of that waste coming from non-plastic sources, but everything else is some sort of a plastic material, including single-use plastics and the plastic waste coming from fishing gear. And here you can see the results. The pollution, the effects on animals, the effects on food chains, how it affects the soil, the growth of trees. It is not just a matter of pollution and the undesirable aesthetics associated with that. It is much, much more critical. It is a matter of life and death, not only to animals, but also to human beings. So if we talk about the consequences, we are talking about habitat and ecosystem alteration. So this gets into the ecosystems. It changes the soil. It causes soil erosion. And birds start building their nests with plastic waste lying around. And marine species are killed by the plastic litter that enters the ocean, and it harms wildlife and their food sources. These animals end up eating the plastic matter because they don't know any better, and they end up dying because of that. And even though it may just seem something simple, like an animal dying off, the consequences are much, much more severe if you think about the food chains. Entire species could disappear. An entire species just disappearing like that is not good for human beings either, because we are all a part of a nexus, a network. It's not even really a chain. It's more like a nexus, a network of interconnected beings. And one node in that nexus getting affected is not good for the balance of other nodes. So the contribution to climate change during plastic production and even during the degradation, as plastics degrade, if they do degrade, they emit greenhouse gases. And the adverse impact on human health. This is, and I will talk about why I selected this particular image of a fetus or an embryo wrapped in plastic. The effect on food and water safety, the economic costs associated with waste management, especially the economic costs that we are passing on to future generations, the impact on sanitation, aesthetics, the impact on the natural beauty, the negative impacts on tourism, and so on. So there's a whole lot of consequences. And I just want to
Microplastics. Microplastics are pieces smaller than 5 millimeters. Some of them are used in cosmetics or toothpaste, but most result from floating waste that is constantly exposed to UV radiation and crumbles into smaller and smaller pieces. 51 trillion such particles float in the ocean, where they are even more easily swallowed by all kinds of marine life. This has raised concerns among scientists, especially about health risks from the chemicals that are added to plastic. BPA, for example, makes plastic bottles transparent, but there's also evidence that it interferes with our hormonal system. DEHP makes plastics more flexible, but may cause cancer. It would be pretty bad if microplastics are toxic, because they travel up the food chain. Zooplankton eat microplastic. Small fish eat zooplankton. So do oysters, crabs, and predatory fish. And they all land on our plate. Microplastics have been found in honey, in sea salt, in beer, in tap water, and in the household dust around us. 8 out of 10 babies and nearly all adults have measurable amounts of phthalates, a common plastic additive, in their bodies, and 93% of people have BPA in their urine. There is little science about this so far, and right now it's inconclusive. We need a lot more research before panic is justified. But it is safe to say that a lot of stuff happened that we didn't plan for, and we have lost control over plastic to a certain extent, which is kind of scary. Together, we can beat plastic pollution.
So, microplastics, the small particles that are a result of plastic production, but also particles that are being removed by actual plastic products that we are using day to day, are everywhere. So if we look at the share of total microplastics that have entered the oceans, synthetic textiles account for a whole lot. And interestingly enough, the next biggest share comes from car tires, and then city dust, road markings, marine coatings, personal care products, plastic pellets, and so on. So microplastics are coming from a whole lot of sources. The amount that is entering the human body per day, it's still being studied. Some sources say it's around a few milligrams. Some say it's up to 5 grams per day. But it's safe to say that we are inhaling and ingesting microplastics every day, mostly through food, but also through water and air. So plastics are continuously fragmenting or shedding fibers in the environment, very small, fine particles that they can just be airborne. And therefore, due to the fact that it's airborne, we can inhale this, but they are also in the water and it enters the food chains. We are eating animals matter that has microplastics embedded in them. So plastics are made from chemicals, a combination of chemicals and additives that can be toxic, that are toxic. And the additives in plastic can also leach into water. And some studies have found that up to 88% can leach, depending on the environmental factors, like, let's say, if they've been immersed in water or if they've been exposed to sunlight. And a lot of species are affected by plastics. The exact threat that this poses has not yet been quantified. So as the human health risk associated with exposure to different elements is a continuously evolving field of study. And certain materials that are not thought to be as toxic today are determined to be toxic tomorrow. One example is lead. Lead was used in paint, children's toys, and everything some decades back, and today it's known to be a big health risk. Similar to that, we are still studying about the effects of plastic, but it is definitely, for sure, it's not a good thing that we are consuming this much plastic. So the average number of microplastic particles found per gram or per liter per meter cube of selected consumables so is very high. It's there in beer, sugar, salt, tap water, air. It's there in everything. So where do microplastics end up? They accumulate in your brain, liver, kidneys, spleen, lungs, skin, stomach, and also the placenta. So you may know that this is a very important organ during the growing phase of a human fetus. The placenta is providing all the nutrition. It's basically the connection of a fetus to its mother. So the fact that microplastics end up in placenta means that humans are exposed to microplastics before they are even born. So the children that are being born today, they are exposed to this from the time that they're in their embryo stage to the end of their life. So how is this going to affect us? We don't know. We think we know, but we have not quantified it to be certain. And we talk about the explosion of cancers. We talk about how cancer cases are growing, and maybe it's a part of this, the things that we get exposed to. And like I said, the exposure pathways include inhalation, ingestion, and dermal or skin contact. And the adverse effects can include abnormal hormonal functions, reduced fertility, damaged nervous systems, cancers, hypertension, heart diseases, and so on. So plastic waste causes environmental damage due to both uncontrolled release and unsuitable disposal. So I think I mentioned the throwaway culture before. Because it's so easy to access and because it's so cheap, we just use plastics and throw them away without even thinking about it. So pollution happens through uncontrolled open dumps, littering, dumping into waterways, release into sensitive ecosystems, and then unsuitable disposal like poor collection practices and improper disposal of hazardous waste, open burning, where the plastic matter gets burned and it can release toxins, improper recycling practices, unengineered landfills, which cause the toxins to leach into the groundwater and the soil, and so on. So what is the solution? So this is a systems change scenario that was presented in one United Nations Environment Program report. This is the situation right now, and this is their expected situation. So instead of just dumping waste, there's solutions that we can incorporate to sort of mitigate the problem. One thing is reducing, definitely reducing the amount of plastics that we use, eliminating the use of plastics. Maybe if we don't need a package for a certain thing, think about how to not use that packaging in sales and marketing. And then reusing or repurposing. And then substituting plastics with other materials like plastic or compostable biomaterials and so on. The next step is recycling. We can have mechanical and chemical recycling to deal with plastic. And then we can dispose in landfills or incinerate them, but through controlled measures that mitigate the harm as far as possible. So mismanagement is when you do open burning or just dump it in a way that contributes to terrestrial pollution or ocean pollution. So with a systems change scenario, they're hoping to reduce the amount of mismanagement and increase options like reduction, substitution, and recycling. So this is a scenario that they say is feasible within the existing technologies and within the existing constraints. So it's not easy to get rid of plastics, like I mentioned earlier. So there's a global plastics economy, and we can't just get rid of everything overnight. So there's the scale and speed of making this transition is constrained by so many different things. So we have to think about the technological feasibility, but also economic, social, and socioeconomic factors when we try to do this. So if we move from the business as usual scenario to the systems change scenario, as you can see, the amount of mismanaged waste is expected to reduce by as much as say into by up to about 1/5 of the current quantities. And they're also hoping to reduce the amount of fossil-based plastic generation by more than half. So the 3 Rs of waste management, reduce, reuse, recycle, can definitely help with the plastic pollution crisis. In addition, we have to find better alternatives and adopt circular economy principles. So avoiding single-use plastics and bringing about policies that ban single-use plastics, designing plastic products for minimal use of plastics, and try to reuse, repurpose, and recycle as far as possible. So think about these aspects in product design itself. Rethinking packaging practices, better waste collection and disposal, increasing the recycling infrastructure and access to recycling infrastructure, especially in developing countries where there's a big gap between the expectations and practice. Extended producer responsibility laws, where the producers who produce plastic have to take responsibility for the end-of-life collection and disposal. So they have to bear the economic burdens of end-of-life disposal. And this leads to much better outcomes. If you are footing the bill for something, you try to think of better solutions. So in order to incentivize product design with minimal plastic use and recycling, we definitely have to adopt extended producer responsibility laws that shifts this burden to the producers. Shifting from a linear economy to a closed loop circular economy model, shifting to biodegradable plastics and other alternatives, changes in policies and regulations, these are all needed. So looking at the current scenario, a majority of the citizens in these countries would actually support a ban on single-use plastics. So that's a good thing. Attitudes towards this are shifting. And the progress that has been made. So if you can see these big companies, Coca-Cola, PepsiCo, Nestle, Unilever, the use of virgin plastic is reducing. So they have reduced the amount of virgin or plastic or non-recycled plastic use. So they are making good progress towards recycling. But this alone is not going to solve the problem. Some people do actually say that recycling is actually a hoax. It doesn't solve the problem at all. And we have to get rid of plastic and replace it with something else to actually make a change. I personally think that recycling has to be a solution under consideration, at least under the current scenarios, because due to a whole lot of practical reasons, we are not going to be able to get rid of plastics that easily. But we do have these alternatives like bio-based or biodegradable compostable plastics. So bio-based plastics are fully or partially made from biological resources rather than fossil fuel material. So they are not necessarily biodegradable or compostable, but the idea is that in most cases, bio-based plastics are developed so that they are biodegradable. And then there's biodegradable plastics that can be made from biological resources or fossil-based material to biodegrade under certain conditions. For example, there are smart biodegradable materials that only biodegrade under specific environmental conditions, or there's additives that are incorporated into normal plastic to make them biodegrade or to accelerate the process of biodegradation so that they don't take centuries to biodegrade. And we spoke about a circular economy. Some people introduced the idea of circular economy in the chat as well, which I appreciate. So a circular economy is a system where materials never become waste and the nature is regenerated. And that is the idea. We are using natural material, but we are trying to regenerate nature as far as possible. So we try to keep products and materials in circulation through maintenance, reuse, refurbishment, remanufacture, recycling, and eventually composting to become the raw material for maybe the next generation of plants or natural matter. So a circular economy for plastics means that we have to completely rethink the way that we design, use, and reuse plastics. And we need enhanced collection, sorting, and technologies to recycle mixed waste plastics. So it's not very easy to recycle plastic, especially if it is a mixed stream of plastics. Different types of plastics have different recycling mechanisms, and it's not possible to just mix everything together and then throw them into some machine and to have them recycled in most cases. So we need better technologies that do accommodate for mixed waste recycling, just because in some cases it's very difficult to separate different types of plastic. So you can see consumption, products in use, and waste getting generated, but we are trying to minimize that so that it's sent for recycling and then reuse to be converted to the next generation of products. Other like solutions and good practices that can mitigate the problem: separate collection, that leads to much higher recycling rates; eco-design of products to increase the recycled content, and facilitating the reuse of components in the next production cycle. So managing the plastic waste so that it can be converted to new resources or to reduce the fossil-based feedstock, and using circular feedstocks wherever possible, where you create a connection from the end-of-life waste to a new product. And I'll talk about circular feedstock in just a bit. So we can have feedstocks coming from biological origins like corn or biomass, or we can use actually carbon captured from air to use as a feedstock to produce plastic. So carbon capture is an area where more research is needed to see how it can help with the plastic crisis. Carbon capture can be used to capture carbon dioxide or methane, for example, from emissions from power plants or boilers and so on before it enters the atmosphere. The captured carbon can be used as a feedstock to produce plastic. Another good thing is that carbon capture can be used to mitigate the emissions during plastic production and also during the degradation of plastics. Let's say we have enhanced accelerated degradation processes for plastics, and we are going to produce carbon dioxide, because that carbon dioxide and water is what plastic is going to degrade into, and we can use carbon capture to capture those emissions. So I'm not sure whether we have the time for this. I'll just go over at least the first few, the first couple of minutes.
Recycling just makes you feel good. But what actually happens to all the plastic bottles? This does not happen. Bottles do not magically become fresh new bottles. The story is actually much more interesting. We're going to focus on polyethylene terephthalate, or PET, the type of plastic with a 1 printed on the bottom. The ethylene terephthalate refers to this. String a bunch of these together and you get polyethylene terephthalate, a durable, flexible plastic that can be heated up and molded into lots of convenient shapes. After you recycle a plastic bottle, it gets hauled off and sent to a recycling plant. They take off the labels and clean it and separate all of the PET bottles, not just from the glass and metal and paper, but also from the other kinds of plastic. That's because different types of polymers do not always play well together. For example, polyvinyl chloride, which most of the pipes in your home are probably made of, can totally ruin a batch of PET. You have to heat up a batch of PET so much just to soften and mold it that the PVC will start to chemically break down and produce hydrochloric acid, which can actually degrade the PET. So sorting is super important, and so is cleaning to remove as much impurity as possible. In this case, that includes both things like that last backwashy sip of soda and other kinds of plastic. That's one major factor in why it's both hard and expensive to recycle bottles into more bottles. But when the plastic isn't good enough for recycling into more bottles, it's still sometimes good enough to spin into fiber for clothing or carpets or whatever else you use fiber for. Which, incidentally, is now called polyester, even though chemically, it hasn't changed. That's right, most polyester and PET plastic are chemically the same thing. The plastic is just ground and shredded and melted until it can be spun into thread and then woven into fabric. This type of recycling is sometimes called downgrading, because once the plastic becomes fabric, it can no longer be recycled again. There is also a form of recycling that changes the chemistry of PET, and is in fact called chemical recycling. It requires putting enough energy into the plastic to break the chemical bonds holding the polymer together, converting PET back into its individual parts. These molecules can be used to remake PET or even made into different types of plastic, but chemical recycling is really expensive, so we don't do it very much. So that's why bottles become clothes and not new bottles, because making bottles requires super clean plastic, and that's tough to get. But even though going from a plastic bottle to a handbag is technically a downgrade, at least it's much cuter now, right? Right?
So yes, recycling is not as simple as it looks, or as it's more complicated than people make it sound when they discuss the option of recycling. There has to be sorting involved, and there's different processes that you can use to recycle, but it really depends on the type of plastic that you're looking at. And even when we talk about chemical recycling, we are talking about different processes like depolymerization, pyrolysis, and gasification. And interestingly, pyrolysis and gasification can also be used to produce fuel out of plastics. Pyrolysis can be used to produce fuel. Gasification can be used to produce syngas. So this is one way of recovering energy from plastic waste. We can also produce what we call refuse-derived fuel, or RDF, where plastic and waste mixed together as shredded and then formed into pellets that can be used in cement kilns or incinerators as cheap fuel. Plastic waste can also be used in the construction industry. It can be shredded, melted, and then molded into blocks that can be used for construction. These are usually more lightweight, and they're durable and water resistant. They are also used as aggregate matter to go into the concrete. So an alternative aggregate to replace sand in concrete. So in the new plastic economy, we are looking at renewably sourced virgin feedstock, or trying to minimize the use of fossil-based feedstock. We are trying to change the way we design and produce plastics. We are trying to maximize recycling and reuse, and at the end of life, try to recover energy and biodegrade or compost. So these are some of the circular feedstocks that we can look into, like bio-based matter, like cane or corn, and the carbon dioxide that can be captured directly from air. So what are the new areas or the new and ongoing areas of research and development? The production of edible plastics, especially to be used in food packaging, using things like seaweed or rice or other starch matter. And then technologies to remove microplastics, for example, using biofilms for filtration, magnetic nanoparticles. These technologies are under investigation to see how they can help to remove microplastics from water, from aquatic systems. And then the incorporation of additives or say enzymes to speed up the plastic degradation, smart biodegradation techniques, and then using artificial intelligence for waste tracking and management and to ensure and enable compliance with extended producer responsibility regulations and so on. So all these areas are currently under research. People are doing R&D on this. So their success definitely matters in making this shift and making the transformation from the current linear plastic economy to a circular economy and solving the plastic crisis. So I'm going to stop there and then turn over to Dinushika. Are you there? And then we do have some comments on the chat. Yes, I mean, it is not easy to make a shift to the circular economy. It does need a whole lot of collaboration between different levels and different stakeholders. It needs a mechanism, it needs supply chains, and it needs a whole lot of labor, money, and motivation. So yes, it's definitely not easy, and we're for sure not going to be able to do it tomorrow or the next week. And yes, recycling is difficult, and it's difficult for companies to implement, and it's and on the flip side of this coin, a whole lot of environmental activists think that recycling is not of any use, or it's simply not enough to solve the problem. About the presentation and the certificate of attendance, I'll leave that question for the Green Building Council. And about carbon capture, yes, it's under development. Some people are doing this, at least at R&D level, but whether it can be implemented at commercial scale to capture carbon dioxide capture is done in certain industries. But direct air capture and using that to produce plastics, that is a bit of a stretch right now, at least at commercial level. So I'll stop there and turn over to the Green Building Council.
Okay, madam. Thank you, Dr. Hirushie Karunathilake. On behalf of the Green Building Council of Sri Lanka, I extend our heartfelt gratitude to Dr. Hirushie Karunathilake for sharing her time, knowledge, and invaluable expertise with us. To our wonderful audience, thank you for your active participation and engagement. Your enthusiasm and curiosity make sessions like this impactful and meaningful. We look forward to seeing you again at our next Screen Talk session, where we continue our journey towards sustainability and environment stewardship. Until then, stay safe, stay inspired, and let's work together to build a greener, more resilient future. Good night. Thank you.